Alright, so today we're talking about gravitational potential energy and kinetic energy. These are both types of energy, which are also types of work. Alright, so gravity is our force that pulls everything down. Because we know that work is energy, we also know that work is a force times a distance. So energy is going to equal our force times our distance. And the way this works is we want to think about which one has more potential energy. That's gravitational potential energy. And so where does that potential energy come from? Well, if we know that work is energy and work is a force times a distance, the force on both these boxes is going to be the same. So the only thing that's different is the distance between the ground and the box. So this one is going to be our biggest potential energy. So in gravity, we've got a force and we've got a height then. And so this distance is our height. And so we know that force is this gravitational force, which is the weight. And we know that the force of gravity is mass times the acceleration due to gravity. And so we can actually find that the potential energy is equal to the mass of an object times the acceleration due to gravity times the height of that object, which is basically mass times acceleration times distance, which is our force, or our work. So this is our potential energy formula. Now, we look at our reference table, or our three-column worksheet. We've got gravitational potential energy, or GPE. The PE is mgh, where m is mass, g is the acceleration due to gravity, which is 9.8 meters per second squared, and h is height. Our units, we've got our mass is measured in kilograms, which is kg. We've got grams, or gravity in meters per second squared. We've got height in meters, and so potential energy is kilograms times meters over second squared, which is kilograms times meters squared per second squared, which gives us joules, and that's the same unit for work. So work and energy are actually the same thing. We can plug this into our help column, and actually we have three things in the bottom here for our help column. We never really have to solve for G, but we do need to keep it in the bottom here. So our potential energy is mass times gravity times height. If we want to find mass, we say that that is potential energy over gravity and height. That's gravity and height still on the bottom. Height is the height of an object is going to be measured by potential energy divided by mass times gravity, and gravity, if we ever had to calculate it, is going to be potential energy over mass times height. Now, kinetic energy. Every time an object moves, it has kinetic energy. And this kinetic energy is based on motion. That motion is velocity. So if an object is moving, it's going to have a velocity. And so we base that on velocity. But it's not just velocity, because if you move an object, it's going to require some sort of energy to get that object moving. And some objects are bigger than others. And so they require more energy than others to move. So mass and velocity are the important formulas, or important values there. So where does kinetic energy come from? Kinetic energy comes from other types of energies. It comes from chemical energy. It comes from the gravitational energy. It comes from all sorts of other types of energies. And so we can see the object of a tennis ball. If this tennis ball is moving, we've got kinetic energy when you throw the tennis ball up. At halfway, it's slowing down, which means it's gaining height, which means that some of its energy is potential because it's gaining that height, and it's slowing down, so that kinetic energy turned into potential energy. At the very top of the throw, it's no longer moving. If we just pictured it staying still, all of its kinetic energy is now potential energy, and as it starts to accelerate, we gain more and more kinetic energy and more losing potential energy until we have all kinetic energy back down at the bottom. This brings me to conservation of energy. We know that energy can't be created or destroyed, it just changes forms. And just like we know momentum can't be created or destroyed, we know that matter can't be created or destroyed, we know that energy can't be created or destroyed, it changes forms. And heat is that simplest form. We already talked about efficiency, how everything cannot be 100% efficient or more than 100% efficient, and so the energy involved. So everything ends up like heat, and those are an example would be the roller coaster. Think about a roller coaster. At the top of the first hill, it never goes as high as that first hill. The second hill, some of that energy is lost as friction in the wheels. And so some of that energy is gone as friction. And so the second hill is not higher than the first hill. A roller coaster won't work if it does that.
Yep. Yeah, go good all day.
So we have our kinetic energy formula, and our kinetic energy formula is Ke equals 1/2 mv squared, where m is mass and v is velocity. Remember, we said mass and velocity are both equal, or are both parts of kinetic energy. Our units, we measure mass in kilograms, we measure velocity in meters per second, and remember, we're squaring that, so that's the velocity squared, which is meters squared, over seconds squared, and that gives us joules. Same thing as potential energy, same thing as work, same thing as kinetic energy. And so we can actually plug this into our triangle. Again, there's 3 variables here, that 1/2, which we don't really have to put in there. So we have to find all the different things. So kinetic energy is 1/2 times m times the v squared, or mv squared over 2 if you wanted to simplify it that way. We have mass. If I can get past all my interruptions. So if we want to solve for mass, mass is going to be, cover that up, we've got Ke on top and 1/2 v squared on the bottom. So Ke equals 1/2, or m equals Ke over 1/2 velocity squared. And if we want to solve for velocity, we have to add this square root in here. So if we got to solve for velocity, we got v squared equals Ke over 1/2 m. So Ke over 1/2 m, and then we take the square root of both sides, which leaves us with v equal to the square root of 2Ke over m. If you have to stop and pause this while you're writing stuff down, please feel free. If you need to go back and review it, go ahead and do that, and I hope you enjoy doing this way.